Marco.
Sean.
Welcome.
Thank you. Thank you for having me. I'm not sure I know why I'm here, but thank you.
Me neither. Me neither. You drove up, honked your horn, and said, "I'm coming on this show."
You say you want to join me. I'm like, sure. I got nothing to do, so why
join
not?
me on this ride. Join me on this ride.
Literally,
be a backseat driver.
I heard.
Exactly.
Literally.
Nah, this is cool. Thanks everybody for joining me. You're all very welcome to a new episode of Redefining Cybersecurity Podcast, and this is Sean Martin, your host, of course, where I get to talk about all kinds of cool things cybersecurity related. Most times, as it hits businesses and operations, and it's hard to disconnect that from the real world. That's why I brought Marco on as well, because the topic today, which is automotive security, definitely touches the real world, right? So certainly those organizations, manufacturers and systems operators and huge supply chain entities have a lot to worry about on their own, but all of that stuff ends up hitting the roads and everything else that we do in our lives. So I'm thrilled to have Scott Sheahan on. Scott, thanks for joining.
Glad to be here, guys.
And this was inspired by a post that you made on LinkedIn, which I'll include here. I encourage everybody to have a peek at that. There are countless resources that Scott provided and some of the other folks commented with even more. The whole point is, why should we be concerned about cybersecurity, and how do you get involved in helping to improve the safety of cars from a cyber perspective? And Scott, I'm excited to dig into this with you, and I'm interested to hear what Marco brings as a backseat driver on this chat.
I want to hear, and I already think I have a few questions in my head, but
I'm sure you do. You're going to ask that one more question at the end, I'm sure. But before we get there, Marco, I want to know who's in the car with me today. Scott, a few words about you, what you're up to.
Sure. I'm a Hoosier now. I live in Indiana and have been involved in the automotive industry for about 5 full years. Before that, I was an embedded software developer in the defense industry. And so aerospace and automotive are pretty similar industries. Transitioned over mainly because I didn't want to have to deal with classified labs. And it's been a lot easier with remote work. But so I've been involved with securing embedded and connected systems in cars for different OEMs and tier ones. That's what I do day to day, and I enjoy the industry and really like it.
I love it. And Marco, of course, is the host of the Redefining Society Podcast, where he connects technology to the impact of everything on it. You want to say something about your show, Marco? People who know.
That's pretty cool.
It is cool. I don't seem to get invited to that one anymore.
Yeah, you do. We don't go technically deep in things like you do, but it all bounces around, right? You know, like right now, Scott just said, aerospace and cars is not that different. That already like, wait a minute, you're gonna have to explain me that. Until I get flying cars, I don't really see the connection. So, you know, one-on-one on why that's the case could be some place where we can go, and that's usually where I go with my show. Yeah. So, Sean, thanks for asking.
Well, let's start there. What are some of the similarities? Because you said embedded a few times as well.
Yeah.
So maybe kind of paint a picture of the world of automotive infrastructure and maybe what folks need to know on that front.
Yeah, so I think I related the two because they're transportation industries and mobility industries. And so aerospace, automotive, they're very heavily reliant on these embedded systems in their architectures, whatever, for the vehicle architecture. There's all these different control units inside of it that have very specific function. One might be to control the different door functionality or windows, your infotainment unit. And now, I mean, nowadays, the concern with cybersecurity is very recently, talking about in the last 10 to 15 years, we started to hook these all up to a sub-component of the internet, right? So there's telematics units, mobile modems, 4 and 5G modems that get put into these vehicles. And so now that you have connected these embedded systems to a larger amount of, the internet, there's a lot more risk involved as far as cybersecurity. So the industry has adapted over the last 10 years, especially, and it just it keeps things interesting. It's a new world regarding connected cars in the future with hooking everything up. I mean, it's not just cars. It's you guys know IoT, cars, airplanes. It's all hooked up to the internet in some
cities,
sense.
critical infrastructure, you name it. Throw an internet connection on there. You used plural version of 4G and 5G routers or modems. Are there more than one in a car?
I guess I'm just trying to highlight the transition in the modems as well over the last number of years for modems that may have just been 4G support, and then others that may have the backwards compatibility, but they have 5G.
Okay,
but you also have to, you usually have to remember these cars are on the road for a number of years, and so you have connected cars from before 5G that they got 4G modems, and I mean my phone, I guess right now I think technically has a 5G interface, but I don't use it. It still uses the 4G interface. So yeah, it's all this backwards compatible technology that just keeps building, and you guys know for cybersecurity that just causes companies headaches because there's a lot to maintain, and a lot of, if vulnerabilities are found, there's a lot to be done in the area of responding to it.
So sorry, can we assume that every car that you buy now, or I don't know when this started, is pretty much connected? Because I don't think people go like, oh, I'm not going to get that car because that's connected. I'm not going to get the connected fridge. But
yeah,
the car, do you have a choice anymore?
It depends on the OEM. And to my knowledge, some are, almost all of their models are 100% connected because their business model relies on it. There are other OEMs that have your lower end models that don't. But I think as a business case as well, the OEMs are realizing, hey, there's a lot of valuable data in the car. If we have the modem, we can stream it back, and they make a business case for it that they'll include the modem. It's some additional cost into the bill of materials, but it provides them with insight into how people drive, the surroundings around people, the sensor data that's being read in from your vehicle, and going to improve, the different types of autonomous or driver assistance technology. But I would say, most businesses now are defaulting to the connected vehicle because of that aspect.
So I can probably think of, I don't know, 10, 20 different use cases where I'd want a bunch of data from the car and have it available to me from an individual car, from a particular model, from a particular region, from, I don't know, slice and dice this information for different reasons. There's I want to improve the efficiency of the car. I want to improve help steer folks in the right direction from a traffic perspective, or help with insurance policies, or you mentioned some of the business cases where I presume it's your car is due for service because of the way you drive, you maniac. I don't know. Those are some of the things that come on top of my mind. Are there other scenarios where this becomes important, or at least in somebody's mind important?
And I would say another one that I didn't highlight is over-the-air updates, just as far as maintaining your control units and patching the firmware. So for cybersecurity stuff, if you have to release a patch, now you don't have to have people drive into the dealership to have a technician flash that onto your control unit. You can do it over the air. So that's a big one. I mean, I don't know how many millions of dollars that saves, but for each OEM, that's having the connected vehicle is a big advantage there.
So instead of pulling in and dropping the car off, you sit on the side of the road for an hour.
Or generally they wait till you're parked in the garage, and a lot of them connect to your home Wi-Fi. or a different access point that you've configured, and then they wait for a good time in the middle of the night and update themselves.
Yeah, I rented one and didn't have that option.
Oh, really?
I stopped.
Huh.
Before you could go, you have to wait. So, interesting scenario. Marco?
I don't know. I have a ton of questions, but I want to go maybe where you want to go. So with great power, great responsibility as usual, or great risk. So maybe we can go in highlighting the role of cybersecurity professional in this. As a consumer, again, I would say, well, if you make my car safer, cool, right? But if then I go with the risk of being actually unsafe because I open a lot of door and windows and allow risk into my life, in my driving, actually, where I want to be secure, then maybe a little bit different perspective. So we need the security aspect in here. So what are the main things that we need to look into?
Yeah, I'd say the safety and security element that you mentioned are very intertwined now. There is, as engineers, as we're making the vehicles for these companies, safety is always top priority, right? There's lives at risk. These vehicles have passengers and drivers and other people around them, and so safety has always been top of mind. But now you have the element of cybersecurity in your design, and there is some overlap. Because I've heard the phrase is that safety is pretty static. You cover all your bases, and there's not going to be any like kind of new cases really for safety. You kind of understand them. But cybersecurity is very dynamic in the fact that the firmware that's in these vehicles lives for a long time. The different tactics and techniques that the hackers or state entities are using is changing, and so you have an element of actually dynamic change coming into your vehicle, and that can affect safety. So yeah, I think a lot of OEMs are taking a lot of precaution when it comes to these connected vehicles to make sure they're secure and nobody can take them over on the road. And there is a lot of just representation maybe out of Hollywood that's kind of, it's theatrical, it's Hollywood, so of cars being remotely taken over and a bunch of them being driven remotely, which there's a lot of safeguards that goes into making sure why that is very hard to do. It's theoretically possible, but extremely hard to do.
I think the lesson is not to have a white autonomous vehicle. If I'm thinking of the same movie you're thinking of, where they're all controlled by.
Oh, yes.
But so I want to ask you this, because clearly you said, 10, 15 years now, it's been a topic. I know there's been a lot of progress. I don't know how many years ago it was Marco, I think what did you say, 2015 we connected with Ian Tabor in London? No. 2018. Yeah, somewhere around there. 2018, Ian Tabor and Casey Ellis, the team at Bug Crowd. We're doing some things with some automotive organizations from a bug bounty perspective. So I think there's been a lot of, and I know at DEF CON there's activities and policy folks were being brought together with the hacking community to raise awareness. So I guess my point is there's been a lot of external interest and discussions around the need for cybersecurity investments by the automotive industry. Marco and we have a friend that actually does that in an automotive agency out of Japan. He was hired to help them with that. So I know there's some insight, but I guess I want to get your view of how well has the industry embraced the idea that we need to be more secure?
I'd say pre-2015, people were on the fence, and then obviously at DEF CON, Charlie Miller and Chris Valasek demonstrated the remote hack through the cellular modem to get onto the Jeep's powertrain and be able to they did actually inject some commands. The security engineering was not all that well developed. And post GPAC, I think that's a big, everybody references it. I mean, in the industry, I hear that moment referenced a lot, but we've had a lot of development in this space. And so we're roughly at about 10 years since then. And there's been standards. So we have an ISO standard, ISO and SAE, they came together and made the 21434 road vehicles, cybersecurity engineering for road vehicles. And so that's been a huge effort. And that means that OEMs and tier ones are responsible for kind of best practices in cybersecurity management systems, how to engineer a vehicle, how to engineer an embedded controller, or whatever component it is. You have to go through the proper process. And it's just, when you make something secure by design, because you've gone through all these steps, it comes out pretty good. And when you don't, obviously you guys, you see the news articles when things are not designed securely from the get-go. But I'd say, now we've had that standard was published, I believe it was in 2021. We've had a number of years to go through it, and the OEMs and tier ones are now becoming more and more mature all the time. Their teams are quite large, and there's a lot of investment just to make sure that the engineering design is making these products securely.
There are a ton of parts, and I mean, in the news right now, connecting back to aerospace, a simple thing like a bolt can be missed, right? That can cause a big safety issue.
Yeah.
So that bolt clearly is part of the supply chain to build an airplane. Same for a car. There's a ton of stuff, a ton of physical things, a ton of sensors, a ton of software components. Like, I don't know if there's any one entity that builds it all themselves. I can think of one that might try, but a lot of them probably have a huge supply chain of digital elements as well. So how does that complicate things for manufacturers actually that put this stuff on the line and then out on the streets?
Yeah, that's a excellent part of the industry is this supply chain of, you have the OEM that has a lot of parts, electronic components that are supplied by what we call tier one suppliers. And so they bring these two, there's this overlap of who's responsible for what in the design process that is covered in the standard. And so it is ultimately, the responsibility flows up to the OEM because they're putting the product in their connected vehicle. And so there's shared responsibility, but a lot of the operational risk is taken by the OEM. And so I've been able to work at an OEM. I was working at Ford for a while, and then I got to go to a supplier, Aptiv, and I got to hop onto one of the parts that I was helping with and work at the tier one level, designing that part for cybersecurity. And so this changeover between OEMs and tier ones, it's really important. And I can tell you there's a lot of meetings every week of the OEMs monitoring, like, hey, we have our weekly cybersecurity sync up on this part that you're making, and they want to make sure it's done correctly.
So can I ask you this? Because I keep thinking you buy a car, and not every car is the same. And I'm talking about a price tag on it too. Mm-hmm. You can get a car with, I don't know, 20,000. You can get a car for 300,000, 400,000. And you assume it's a better, safer, more comfortable car. Maybe there is a brand value on it too, but at least the safety. You think it's always been thinking that if it's more expensive, it has more advanced technology, it's probably going to keep me safer. Then we get into self-driving, whatever level it is, that I can keep the distance on the highway or whatever it is, it brakes on its own, and da-da-da. So I know that I'm going to have to pay probably more for more safety. Does it come cybersecurity with a price tag and different level as well? Or when you work on that, you do an umbrella and that applies?
Yeah. More of the second part there with it. Most of those connected components are the same within the connected vehicle architecture. So Renault may have one set of connected components that they use, and Ford as well, their own in-house components that they're just going to reuse across the connected architecture. And then the differentiation, there might be small inputs that are different into the systems, different sensors, sensor packages, camera packages, different, maybe a different infotainment screen. One's like a massive, huge touch screen. But ultimately, the cybersecurity engineering I can tell you from my experience, it's the same as far as, there's nobody's going to skimp on that, because if they have an incident, they know the next big incident, we're talking tens to hundreds of millions of dollars that the OEM has to put out, if not more. It depends. And I think Elon Musk has referenced a few years ago that the fleet-wide hack is what all OEMs are worried about. And I think his particular quote was about the next OEM that has one could potentially go out of business. So everybody's really worried about it. And there's no, like, all of them are going to be as secure as possible.
Okay. So let's talk about some of the activities involved, because I grew up in traditional IT network environment where there are a bunch of best practices. The one obvious one is separate the good stuff from the open stuff, the exposed stuff.
Yeah.
Right? Do a lot of those same practices follow through? And what do security researchers and practitioners have to think about differently, perhaps, in the auto infrastructure?
Yeah, there is a lot of traditional. The IT cybersecurity defense principles are. I would say that the neat thing about a car is you have all of these types, the full stack of, like, you have like really small embedded devices. You have basically a tablet type infotainment display. You have your advanced driver assistance that's doing a bunch of like video processing and machine learning algorithms. You have a cellular modem. You have like all these layers of components that each has their own little security controls that are different than the others. Like securing an Android-based infotainment is not the same as securing like an AUTOSAR-based body control unit or something like that. But the same principles apply. You do a threat analysis and you look at I generally go through the STRIDE type mnemonic and look at the different threats there, securing the network, securing the endpoints, the computing power, the electronic control units. Network segmentation is a big one. And the classic, now automotive Ethernet is pretty prevalent in the vehicles. So you have your Ethernet frame and above, like from there to the application layer, you have your traditional like IP-based defenses that you can put into the vehicle now. And so it's not reinventing the wheel. It's using a lot of your traditional defenses, MTLS, mutually authenticated TLS connections within the vehicle, segmenting the most important modules on one network, and maybe the powertrain gets its own network, and the body control gets one network, and maybe the chassis control gets one network, and then maybe some of the other ones. But yeah, this is all very well thought out. But I would say the neat thing, and what I would say to somebody, why automotive cyber? Well, because it has like everything. It has Bluetooth, it has cellular, it has USB, it has near field, like it has all these interfaces. You get them all in the vehicle, and so you just like every day you're just constantly learning as a security engineer. Okay, how do we use the same secure by design principles, but okay, now it's for a new interface, and it keeps things interesting.
And you're still thinking about, at least I'm thinking while you're talking about the car, one car, or the fleet of car. But then I started thinking about when you talk about edge computing and car communicating one with another in an autonomous environment, or my car knows where the closest car is and how fast it's going. I think you even get more cherry on top of this cake. Like it just get everything. Is that a lot of changes when a car get towards a certain level of autonomy? I mean, I'm assuming there is even more risk, but am I correct or not?
Well, I would say that the traditional security defense, yes, there's more risk because now the vehicle is driving itself, but the traditional security defenses are all about the same. Firmware integrity, then like we talked about, the network protection, the connectivity from vehicle to cloud or edge computing resources. The thing, there's this technology called vehicle to everything technology. I don't know if you guys have heard of that, but the V2X. The thing that's interesting is I look at all the autonomous companies, and my own personal opinion is that obviously if you're making an autonomous system, you can't make it reliant on the V2X signals coming in. So none of the autonomous companies use that technology. Like, oh, okay, that's gonna, you can't, if there's anything that goes out, you have to rely on the onboard sensors, the LiDAR, the radar, ultrasonics, and cameras. And so the funny thing is, I don't know, I'm not too involved with this area, but there's millions and millions of dollars that's been put into V2X and a lot of promises, but I see a lot of people kind of like, the general sentiment is how are we going to actually use it? I mean, in that sense, for autonomous driving, there might be other use cases where it makes more sense, like maybe toll booths. Great, that makes sense. But for autonomous driving, it's kind of a case where there's a lot of critics on it.
Yeah. So the the old CIA triad, availability is key, right? Mm-hmm. And also integrity. I don't know if we want to head down that path or not. Are systems getting jammed with erroneous data to cause stuff? But I want to maybe kind of bring it back to the post a little bit, in that people interested in helping to secure cars. I know you have a ton of resources in your post, as I mentioned at the beginning. Are there any areas you recommend folks? I don't know, maybe there's two types: folks who know cyber and want to enter auto cyber, or folks who aren't in cyber but have a love for cars that want to figure out cyber. On any tips for those folks?
I really, this is in the post, but I really have benefited from the Automotive Security Research Group. It's ASRG, and that's a group that's been started, a nonprofit, just to get a lot of knowledge sharing. It's people from all over the industry, all these different OEMs, engineers, and tier ones. Just kind of we all come together. And during COVID, they've got a good YouTube library of videos. So I used to attend online just their weekly stream. And then now they also have a conference coming up. It's Secure Our Streets. So that's a free conference that they put on for the industry as well. So I'm a big fan of that, because it's like the open source model, right? It's free, everyone's invited, and the knowledge gets shared, and it's good quality stuff. And so generally, there are other great resources where you have to pay. And I as a professional, obviously, I have incentive to pay for knowledge in this area. But that's one thing I like about ASRG, is it's free, and if somebody's getting started, they can go catch up on the YouTube videos. They can go look at, there's probably a local group that they could meet up with and learn about vehicle security. So yeah, in Indiana, I got to go to Detroit or Chicago if I want to get to one, but like a local meetup. But maybe someday, maybe we'll have one here.
There's none around Indianapolis racetrack there.
I was talking with John Heldreth is he's the starter, the founder of ASRG, and I think he told me there used to be an ASRG in Indiana, but it kind of fell through. So, but Detroit's very active, and then Chicago, the guys out of Chicago are pretty active as well.
So I have a question. So you mentioned a lot of things that are related to the safety of the car itself, and often in cybersecurity, the privacy, protection of identity, and a lot of other stuff comes, or at least has come, as an afterthought, but it's still part of cybersecurity, especially if you go in healthcare and other things. And we mentioned this before we started, the Mozilla report that came out a few months ago, where the car is pretty much spying on you, even on your sexual orientation, and you wonder why the hell the car cares about that, or the car manufacturer. Now I know it cares because they get the data, they resell it to someone else, and that's how it works. Are we there where the privacy of the owners is part of the cybersecurity package that company are dealing with, or maybe it's more of an afterthought at this time?
So I will say the 21434 standard I was talking to you guys about, this for engineering, one of the elements for the impact assessment is to look at the privacy specific aspects related to your road users. So that's pedestrians, the driver, other people around the vehicle. And so that is definitely analyzed and has to be shown what data is being kept, just like the different privacy laws that are around. You have to be able to enumerate what it is, all the data you're collecting. However, when you sign up for terms and conditions, right, this is more of a legal thing. You, somewhere buried down in those terms and conditions of the whatever privacy statement, you have agreed to not sell it, but you give it all away. And I was reading actually a different one this morning, and I was like, yeah, some lawyer has made up all sorts of possible data. I'm like, how could they get that from this device? But maybe they do. And they've said this is okay to take, and obviously you just sign it all away by agreeing you're using the service. So as a consumer, I guess you've been tricked. I don't know. I mean, right? I kind of straddle this, like, I don't like it, but also I understand the business case for why companies do it. So there's a business case for it too. The companies that's their job, is to make money. So as a consumer, I'm kind of stuck in the middle, right? And then as a professional, I have a different viewpoint. So,
and most of the time you don't even own the car, so even less. As long as you're loaning or leasing it, or it's not even your car. But I like to wear my 80s kid hat and think back when I didn't have to worry about the stuff. Right? I mean, the car, the only security I wanted for my Vespa was that, the tires are pumped and the engine is working and the brakes are working. That was my cybersecurity guy, the mechanic.
Yeah, and it wasn't spying. Yeah, it wasn't spying on you. Yeah.
Right.
What about this? What about the? Because Marco, you mentioned something that triggered this thought. I forget how long ago it was. We had the topic of the right to repair. So not owning. I know there's a lot of hoopla around the John Deere tractors and whether or not the farmers actually own them or not, and what they can do with the car. So I know, at least at some point, it probably still happens. You can plug into the bus and change the way the car works to remove limiters or boost the turbo or all that kind of stuff. Go ahead.
A lot of that is going to be dying out, or it's exactly with cybersecurity, what does the OEM allow you to change if they do?
So is that under the guise of providing better safety, or is it protecting themselves, or what is it? As a professional in this industry, that I've helped implement a lot of this access control, the algorithms, the design of this for these modules, I have an appreciation more on the side of, like, it has to be done to keep the device secure. And that's the argument that's made by the OEMs. And I generally back that up, is that for locking down firmware and making it so not just anybody can replace the firmware and tune the different calibration parameters, or, that's a cybersecurity reason why you do that. But at the same time, the consumer can't just be like, okay, so you have to go to the OEM shop to get it repaired. So I think that I've seen, at least in the industry, the solution is there's going to be like different
for the access control, there's different levels of control you can request from the OEM. Say, hey, I'm a maintenance tech. I need to change this very specific thing on my module to repair my car. They're going to give you a token, a cybersecurity token. It's like, okay, now you're going to load it electronically over the bus. But once you load that token, now you can make the changes that you might need to make. So there's that. It's the balance, and I think the industry is adapting to that, where you're going to have more. You're going to have to put into a system, state why you need the access, but then the access will be given, because I think that's at the root of right to repair, right? If you're going to have a device, you should be able to. I mean, yeah, I realize there's various degrees of what you should and shouldn't be able to do, but for security as well, the financial risk goes to these OEMs that are making the devices, and their reputation is on the line. So they want it as secure as possible, and I think that's a good thing.
So I'm going to go. We're coming up toward the end here, so I'm going to stick with a more technical bit, and then maybe Marco has one more philosophical mind blower question to throw at you. But looking at the ecosystem, not just the supply chain of building, but the ecosystem with which these vehicles operate. So I'm talking about the cellular networks and the cloud systems, and I don't know, whatever else is out there. Are there any areas in particular, and you can look at the supply chain as well, but are there any areas in this ecosystem where we should be paying a little more attention that we're not?
Yeah, that's a good question. So you're saying in the operational environment, like of the vehicle.
Yeah, I think
driving
we've
around.
done a lot about the building, some more about the operations. Are cloud providers connected to this stuff? Are they ready for whatever the amount of data, the types of data, the access to the data? I don't know.
Yeah, and on that side, the OEMs are working with whatever their preferred cloud provider is to have, whether it's a private cloud or that they own and control, and it hooks up to the car to provide, I don't know, whatever connected resource it is providing. That's not an area. I guess my expertise has mainly been in vehicle.
Okay.
Like inside the vehicle network with these controllers, and so maybe nothing huge is coming to mind as far as the focus on. But that's probably because, like I said, it's my expertise has been so much in vehicle that I just drawing a blank on it.
Yeah, because the cloud is one that first came to mind, but then as I'm sitting here thinking of the connectivity, there's a lot of conversation around API security, right, in the software world.
Yeah.
So I don't know how things look in the automotive world in that front.
I would say generally the general architecture is the vehicle is either using mutually authenticated connections to the back end, and also it could be even inside of a VPN tunnel. I know some OEMs use the connection is all inside the encrypted VPN tunnel, and there might be even additional layers as you pass through that tunnel. But that's pretty well secured. But as you say, I think there's an annual report about connected vehicle security that comes out, and a lot of the effort, if you were going to hack an OEM, would be to get into these back-end systems. So yeah, there's Tesla has, like, I think they call it the mothership, and the other OEMs have their own connected vehicle back-ends that's going to help update those vehicles. The telematics data gets streamed back. So yeah, if you were a nation state that really wanted to disrupt an OEM, you would have to. That would be the place to go. And I think the manufacturers are also seeing attacks on their own manufacturing plant environments too. So that's an interesting place. But I will say there was like a Fast and Furious video where like every single OEM at once got all hacked, and like the time, yeah, that's Hollywood again. The time to do that would just be the very specific technology for all of those different brands would be you'd need an army, and maybe maybe somebody has that, but it would be very hard. I mean, you're going to be expending a lot of resources just to get into one brand of connected vehicle. So
as you're talking about breaking into the back end, all I can picture is busting the lock on the trunk.
Oh yeah,
and you're in. Woohoo! Yeah. Fold the seat down, you're inside. Marco, what do you think?
You want me to go philosophical? Okay.
Sure.
So are you familiar with the ship of Theseus? There's the thought
I'm
experiment. All right, it's simple. It's a thought experiment where if the ship is change all the parts in repair, it get to the point that it doesn't have the original part anymore. Is it still the same ship or not? Right? So
okay.
My question here is I'm following all of these, and I'm in technology, I'm in cybersecurity, but I think about sociologically speaking, and I'm thinking like, when is a car not a car anymore? Meaning, we're not in control of the car anymore. It's just gonna drive itself. It's gonna send all this data. I don't feel like anymore the joy of even driving the car, given I grew up driving stick and having fun with it.
Yeah.
Do you know where I'm going with this? Is it just the tool is not
right.
a car anymore? What's your thought on that? I'm assuming you are into this because you like cars. But
yes. Well, I my immediate thought is that technology is in constant progression. So I always think back to like the early 1900s when the car was just being on the road, and people were like, "Hey, we really like our horses," and it was threatening that industry. And obviously, we don't. In Indiana, there are some horses on the road. It depends on where you're at, but we don't have that many horses. Riding your horse is more of a hobby now, and I think I've heard that argument that as we go into more autonomous vehicles, driving a car I enjoy driving a stick shift, and there's a fun element to that, and same with but I think I forget what the book is, but it talks about like the last person to own a driver's license has already been born or something like that. And I don't know, there's been so much focus on the claims made by the autonomous car industry, that we will see if they clear up as fast as it was promised. Everything has been much slower, and I remember a few years ago, right? The promise was there's going to be all sorts of, by now, self-driving level 4 or 5 autonomous cars, and we don't have them, and so we'll see. But I think as the vehicle becomes more and more autonomous, drivers are removed from the operation of it. Yeah, it does. It starts to feel less like your traditional car.
Yeah, I'm done.
Plane's still a plane. Plane's still a plane. The pilots don't do as much as they used to either. But
well, it flies. The car is still gonna drive you, but you're not driving the car. So my idea is it becomes more of a public sort of transportation. Like as you jump on a train or on a plane, somebody move it for you. Maybe it's a computer, maybe it's remotely someone else. But I don't know. The idea, Sean, we spent time watching those guys in the UK, destroying cars for many, many years. And,
yes.
I like that.
Yeah. And there's a clip I came across the other day. It was a chef on a morning show, and the morning show host said if you just put ham in this pasta, it would become a carbonara. And the guy said, yeah, and if you put wheels on my grandma, she becomes a bike. So, it just seemed funny as you were talking about replacing parts on a sheep. It becomes something else, right?
Yeah, it is.
Yeah.
So when is a car not a car? Well, we'll leave that one there for people to ponder. And as they do, read some of the resources that Scott shares in his post, which of course I'm going to link to as well. And loads of books, loads of videos, loads of organizations. Of course, there's probably a ton more And I would encourage you to either comment on the post for this when it's shared, or on Scott's post to help that group as you find your own stuff that's helpful. The idea is to get people to think and participate. And with that, Scott, I want to thank you for a great conversation, a good view into the state of cyber in automotive, and the need for more people to get involved, for sure.
Well, thank you guys. Thanks for having me on. And the one thing I wanted to say near the end is the industry needs talented professionals. There's a lot of need in this cybersecurity area. So those that are interested, get in with those resources, start reading, and there are a lot of jobs. The industry needs it. So
yeah, toss the imposter syndrome aside and jump on it.
Yeah, just go for it. Yeah.
There's no harm. Marco, thanks for bringing some interesting points to this as well. The sheep's going to stick with me now for the rest of the day. Thanks very much.
Yeah, you're welcome. I really enjoy this conversation. Actually, I'm asking you publicly here. Maybe I should syndicate this on my show, because I turned out to be quite philosophical and interesting. So I hope everybody, not only the cybersecurity people, but the people interested in technology and how it affects our life, will enjoy it. So
yeah, definitely.
I really enjoyed it. Thank you, Scott. Thank you, Sean, for having me.
Yep, fun stuff. And thanks everybody for joining us today. Appreciate you watching and listening. Of course, as always, subscribe, share with your friends and enemies, and keep thinking. And we'll see you on the next one.